Yeah. Unless you want the class one, right? All right, online. Sorry about that, right? Okay, so let's start with quotient rule here, right? So it should be recording now. Right. So quotient rule is if we have right? If we have something looking like this, if we have y is equal to u over v, and of course, we should know that u and v are functions in x, in terms of x. Here's what we do. We're going to use dy dx is equal to, the formula a little bit different, is v by du dx minus u by dv dx all over v squared. Right? Yeah, du. Which one? No, that's x. That's x. So that's dy dx. So I'll try and write a little neater, right? Sorry. Okay, so it's v du dx minus u dv dx all over v squared. Yeah, there are functions in terms of x. This one, yeah, come on, the formula. Kilo. We have to sign up for something, right? Physics here with us or physics in school? Yes. So yeah, that's sign up, right? And we left out the form and signing up. Try to move up. The tighter. Ready? All right. So again, how you'll know which rule to use? Based on the format. Okay? If it's a quotient, you use quotient rule. If it's a product, you use product rule. So you have to look out for that, right? Everybody writing? All right, so let's try this first example here. Right, so let's take a look at example 1. Right, let's say I gave you y is equal to 2x plus 1 over x minus 1. Right, hopefully you should watch it and identify that this is a product, right? Eden, you'll see in there, right? Eden? Yes. All right, nice. So u is equal to 2x plus 1 and v is equal to x minus 1. All right, so are we doing the same thing as before? Find du dx. What's du dx, Darion? Du dx is what? 2, very good. And dv dx, Malini? dv dx is what? 1, nice. All we have to do now is we have to use dy dx is equal to, what's the formula? Is in multiplying the v first. So it's v by du dx minus u by du dx. Sorry. Right? This is opposite to what you would have done in product rule. And then a minus sign in the middle. Okay? And then, most important, people forget to divide by v squared. So watch it here. Just make sure you know what's going on. So you'll get dy dx is equal to, I'm going to substitute v. V is x minus 1. Du dx is 2 minus u, which is 2x plus 1 by dv dx is 1. All over v squared. Right? You can't leave it like that. You have to multiply and simplify the numerator, right? So the numerator will give you 2x minus 2 minus 2x minus 1. Bradley, you have all that? Right, so this will cancel and you'll be left with minus 3 over x minus 1 squared. So you're basically finding du dx, dv dx, and then you're substituting in the formula. Try that here. Let's see how it looks. Very good. Any questions online? Yeah, any questions online? Ariana, Christian, you all okay? All right, nice. Yeah, it's a little bit, well, for now it didn't cut up to that, but it could be tricky when I started bringing in square roots sometimes. Anybody write answer? I'm gonna give you one to try. That's it. Finished? Yeah. Try this, please. Take your time. Simplify as far as possible, right? Simplify it all the way, right? Simplify all the way down. Maybe I get you. So that'll be what? So u is equal to 3x minus 2. And v is equal to 4x minus 1. Huh? So du dx is 3, dv dx is 4. That's okay? Plug it in the formula and we'll get dy dx is equal to 4x minus 1 by 3 minus 4 by 3x minus 2 all over 4x minus 1 squared. So dy dx will now become 12x minus 3 minus 4 by 3x, that's minus 12x, minus 4 by minus 2 is plus 8 all over 4x minus 1 squared. So check back the signs, right? Generally, people make mistakes by the sign, just like Jacob right here. Right? The x will cancel. Minus 3 plus 8 is 5. 5 over 4x minus 1 squared. Anybody got that? Yeah? Yeah, nice. Well, let's get one from here. I want to show you trigs after this, and then we will come back and do some more.
Trigs in this topic. Or the trigs in the
Trigs, yeah, trigs. Yeah, but anybody writing? Esther writing? Okay. All okay with us? Kayla? Alini? Online? Any issues there? Christian? Richard? All okay? All right, let's go again. Take your time and simplify, of course. Next one, try this here. Number 3. Y is equal to 3x squared over 4x minus 1. Take your time. Right, so today we're trying to finish up differentiation, and then we're going to learn where and when we apply this. Okay? Yeah, give me a minute again. You guys out? Up I reach. Yeah, the over it's up. So the differential of this is not 9x. 2 by 3 is 6, sorry, it's 6x. Bring down the power, 2 by 3 and minus 1. Huh? No, watch. You bring down the 2, multiply by the 3 and minus 1. So it's 6x to the 1. Right? We gotta bring the power in front. Right? I will get it e over here. I'll multiply 4, negative 4 by negative 2 is positive. Oh, that 4, because the 4 in front here understood. So everybody 4 here is negative 4. Or you can multiply negative by this, you'll get negative 3x plus 2. And then 2 by 4 is 8. You have to consider that minus. All right, let's go. Right, first thing first, write down what is u. Write down what is u. And write down what is v. Right? The differential of u, bring down the 2, put it in front of the 3. 2 by 3 is 6. Minus 1 from the 2 and you'll get 1. Yeah, Jaden? What's the differential of 4x minus 1? The answer is 4. Right? Then we come to the formula now. Y dx is equal to v, which is 4x minus 1 by 6x minus 4 by 3x squared all over v squared, 4x minus 1 squared. So you're going to get 24x squared minus 6x minus 12x squared all over 4x minus 1 squared. Don't try to expand the denominator. Leave it like that. Right? Hardly have any situations where we actually expand it out. Right. Good job, Katrina. Okay then. Right, so so dy dx is 12x squared minus 6x over. Did you get that? Yeah? Yeah, Pete? All right. Before we go on to harder ones, I want to show you how to differentiate tricks. Okay? Harder meaning, what can make this harder?
Tree.
And square roots and then. Okay? So before we go on to that, head up differential of tricks. Okay? We have to learn to differentiate trig functions now. Oh, let's stop playing now. Who's it, Chetan? Why are you inside it? That's you, Ryzen.
Oh, that could be me. My phone is off. My phone is off. So when if it's not that, so I was saying something, right? So if I have to search on progress, then what I say that to my notification.
Yeah, because you know log over there.
I know what to say. Before I was here, it's bar.
All right. Next heading, differential of trigs, right? Everybody would have heard of trigs already. Y'all know when they say trigs, what they mean, right? Sine and cos, right? All right. So we need to be able to differentiate traits, right? So the rules that we have to learn, right? Just two rules basically we have to learn. The first rule is if we have to differentiate, right? The first rule is if we have to differentiate sin x, the differential of sin x is cos x. That's it. Whenever you see sine and you have to differentiate, like cos. And the second rule that we have to learn is the differential of cos x. Who could guess? Negative sin x. So I must sit down in front. Right? Negative sin x. So we have to learn those rules. Why does it not see in everything? There's a big part underneath here that we're not seeing. Right? So the differential of cos x, right? You don't remember? Nah, no tan for now. Right? In fact, that's a real good question, Malachi. Here's what Malachi asks, right? What is the differential of tan x? So, try this here, Pama. See if you can figure out what's the differential of tan x. Huh? See if you can figure it out. Right? There is something that we just use that will help here. Anybody else? What's that? Tan is what? So since tan x is equal to sin x over cos x, very good, right? Right, we can use the quotient rule. Go ahead, have fun. Try that there for me. Differentiate that for me. Use quotient rule and differentiate sin on tan. Sorry, sin on cos. You understand what to do? So go back and use quotient rule, right? Of course, you'll recognize that here is your u. And here is your v. Use quotient rule and see if you can differentiate this list. Yeah, correct, Aidan, but we're not using that version, right? But that's correct. All right. Right. So you will need a little bit of tricks to simplify this properly. Yeah. You can something on top. See if we can simplify the numerator. All right. So u is equal to sine x. U is equal to sine x. V is equal to cos x. Okay. What is du dx? Du dx is cos x. That's what we just learned. And dv dx is what? Minus sine x. Now let's plug it in the formula. So the formula is v by du. So that's cos x by cos x minus sine x by, that's a minus sign there, right? By minus sine x all over b squared. Right. You all may not see, so I want to turn this slide, right? Right? What you all got for the numerator? Cos squared plus sine squared, which is 1. Very good. So the answer is 1 on cos squared. Right? And as Eden pointed out, that is sec squared, but that's not on his syllabus. That's not on his syllabus.
I tried to join us myself.
Right, so I'm not sure if you all seen it, but on top you will end up with cos squared x plus sine squared x all over cos squared x, which is 1 cos squared. Right? So you have to know your little trig rules, right? Copy down. Let's try next one. Same thing if you want. It'll be. Oh. All right, nice. Let's go again. Right, before we do our next trigs, sorry, before we do our next quotient rule, how do we differentiate this? How do we differentiate cos 2x? What's the differential of cos 2x? So I'll have to show you the long way first.
Minus
2
minus 2 sine.
Very good. Minus 2 sine 2x, right? So I'm going to show you the shortcut method first. Here's what you'll do. So you have cos 2x, right? Differentiate 2x. How much is that? 2. What's the differential of cos? Minus sine, and then write back the 2x. Right? That is the shortcut method. The long way is using chain rule. Watch it again for those who get lost there or wasn't paying attention. Malachi, watch here. No, let's say watch here. The differential of 2x's, the differential of cos's minus sine, right? And then you write back the 2x. Right? So you differentiate 2x, then you differentiate cos, and then you write back the 2x. Method 2. right? Method two is where we're going to use chain rules. Okay. So we could let you, watch here please. We can let u equal to 2x. Right? We can let u equal to 2x. And then you chain rules. That's what I showed you all last week, right? So we'll end up with du dx being equal to 2. Y is equal to cos u. So dy du is, what's the differential of that? Adele? What's the differential of cos u? What's the differential of cos x? So what's the differential of cos u? Negative sin u. Okay? So therefore, dy dx is equal to dy du by du dx. dy du is here. That's minus sin u. Du dx is here. That's 2. So that is minus 2 sin u. Right? So your final answer is minus 2 sin 2x. Right? It's a little bit longer, but you have to be able to use chain rule as well. Right? So you basically have to do this. That's okay? If the question doesn't say, you're allowed to use shortcut rule, right? Yeah, I'm sure what I mean. So the shortcut rule, remember, differentiate 2x, differentiate cos, and then write back 2x. That's the shortcut. Copy down chain rule as well. Copy down chain rule. Which chain rule? Your chain rule? Yeah. Oh yeah, you're not seeing that. The differential of u is 2. Yeah, du dx is 2. I have to remember that now, eh? I've tried this here. Number 2, find the differential for me. Find the differential of find the differential of 3 sine 4x. Any method you want. Any method, choose one. If you want to be safe, use chain rule. Make a substitution for 4x something, right? Find the differential of 3 sine 4x. Any method you would like to use. Right, so using shortcut method, help me out, please, Shannon, help me out using shortcut method. What do we do with that tree? What do we do with that tree? Yeah, let's leave it right there, yeah. And then the differential of 4x's, differential of sinus, and then we write back the 4x. Okay, so that tree, don't let it confuse you. Leave the tree right there. So you'll end up with 12 cos 4x. You okay with that, Dylan? No trouble? Why the chain rule? Yeah, well, chain rule should work out. I'm gonna see. So you let u equal to that. Oh, here what you do. So u is what? U is that, right? So that's correct, good. Right, now what's the differential of this? Differential of sine cos, right? So you end up with 3 cos u. And then put it back together. So the 3 though, we go to the 3 computer, differentiate here like normal, and then multiply by 3. Right. Since we're here, what are we going to do here? What are we going to do to differentiate here? Y is equal to 2x plus 1 over cos x. Are we differentiating that? We're going to use quotient rule. Very good. Go ahead. You use quotient rule. Malachi, u is what? And the v is? Nice. You learned something. Nice. All right, bye. Right, nice. Continue there, please. Take your time and let's differentiate that out. Right? That combines everything you would have done. And then let's try one hard one and we can wrap it up there. Yeah. Right, so du dx is what? Du dx is? dv dx is minus sine x. Very good. Now we can jump to the formula. dy dx is what? Remember, it's v by du. So that's 2 cos x minus u by dv. That's minus sine x, right? all over b squared cos x squared. So we'll be left with 2 cos x plus 2x plus 1 by sine x. No need to multiply it all because it's not going to look any nicer. Right. Somebody wrote this cos x squared, right? That could be read as cos by x squared, right? So whenever you want to see cos squared x, you could do it like this, or you could write on the outside. Anyone you want, right? So be careful where you put that squared sign. You're squaring cos, not the x. Yeah, can't do anything else. There's no factorization or anything. If you multiply it out, nothing wrong with that. Gosh, boy. Oh, here, how do you find? You find here how?
No. All right, so I'll leave that done, right?
Yeah. Yeah, send it out today. For 6.
I can swim it on like.
All right. Yeah. Let's try one more and we wrap it up, right? Right, I'm gonna give you a hard one. Let's square root in it, right? I'll bring the wrong book. Do I want you to bust your brain, right?
Not into it because I'll be in trouble. I'll just say I can do it and I'll be in trouble. Sorry, sir, but if you
What number we on?
6.
Huh?
6. No, number 4. Number 4.
Right, try this please. 2x over the square root of x minus 3. Take your time and simplify as far as possible, right, Kayla? As far as possible. 2x over the square root of x minus 3. Not give me back the answer in a root. I mean, a power. I want it back in square root form, right?
You see that? You see that?
Right, those who are online, if you want, you could kind of have to type this answer. You could take a pick and send it, all right? Right, dudx is what?
2.
Right, dudx is 2. And remember, square root means what? To the power of a half. So dbdx is what? Bring down the half. What's the next step? Differentiate the x minus 3. Then write back the x minus 3 and then do what with the power? Minus 1 from the power. So that'll be a half by x minus 3 to the negative a half. Okay? So plug it in the formula. dy dx is what? X minus 3. Actually, I don't want the square root. I don't want the half, right? So substitute b by that, you'll get 2 by the square root of all over b squared. Square root of x minus 3 squared. Anybody get lost? Yeah? Someone get lost, huh? Don't be afraid someone get lost. Yeah? Yeah, well, I'm reaching it. Diane, we're lost here. Kanisha. Yeah? So what you say? I had a half by x minus 3 to the negative a half. Remember, negative means 1 over the square root, right? So I multiply a half by 1 on the square root of x minus 3, and I get 1 over 2 by the square root of x minus 2. That's okay? Darian? Anybody else confused? So this here is my dB dx. Do it again. All right, Christian. So when I reach here, the negative sign means 1 over. So it's 1 over the square root of x minus 3. And then I multiplied by a half, and I got this line here. So I simplified my dB dx to 1 on 2 root square root of x minus 3. That's okay, Christian? Yeah? All right, nice. Right, we're not done, of course. That's not the only. We had to simplify that further. Yeah. So now we'll be left with dy dx. The numerator is 2 by the square root of x minus 3. Shannon, does you there? Stay quiet now. 2x over 2 all over x minus 3. How do I simplify that numerator? How do I simplify that numerator? So the 2's will cancel, right? What we can do? Are you listening? What we can do? 2 fractions. So what you can do? Find the LCM, right? So we can multiply the denominators. We'll get 1 by square root of x minus 3 is the square root of x minus 3. And then so you're multiplying usual steps, all the usual steps. This multiply by this, and then this multiplied by that, and then 1 multiplied by that. Okay? And put the minus sign in the middle. So you'll get 2 by x minus 3, root x minus 3, by root x minus 3 minus x. So underneath here is x minus 3. Your numerator, what is the square root of x minus 3 by the square root of x minus 3? What is this here? That'll just be x minus 3, nice, minus x. Instead of divide here, I'm going to put multiply. So you'll be left with 2x minus 6 minus x all over the square root of x minus 3 by x minus 3. Sorry, square root of x minus 3 by x minus 3. So your final answer is x minus 6 over the square root of x minus 3 by x minus 3. Right, so you see what makes this a little bit harder? You have to simplify this. As well as make it a little more challenging. All right, copy it down. Here we share. Where we share? So where you go? All right, copy it down.